Okay, today's lesson is to use isosceles and equilateral triangles. When an isosceles triangle has exactly two congruent sides, these sides are called the legs of the triangle. Well, if it has two congruent sides, that's what makes it an isosceles triangle. So anytime you have an isosceles triangle, then it's got two legs on it, which are the two sides that are congruent. So this would be the leg, and this would be a leg. Then the angle formed by the legs is called the vertex angle. So that would be the vertex angle at the top. The third side is called the base. I'm all about that base. Then the two angles adjacent to the base, which means like and next to the base, are called base angles. So these two angles down here are called your base angles. Theorem 4.7 says, well, it's the base angles theorem, or BAT for short. If two sides of a triangle are congruent, then the angles opposite them are congruent. So that tells us that if we have these two sides congruent, then these two angles are also going to be congruent. Next is theorem 4.8. It's the converse of the base angles theorem. So the last one said that if these two sides were congruent, then these two angles were congruent. This one says if these two angles are congruent, then the sides that are opposite those angles are congruent. So this would be CBAT. This is converse of the base angles theorem. In triangle DEF, DE is congruent to DF. Name two congruent angles. Well, these are the legs, and so we have to look at the angles that are opposite those. So that would be angle E and angle F. So you would be able to say that angle E is congruent to angle F. Corollary to the base angles theorem. It says if a triangle is equilateral, then it's also equiangular. Then the corollary to the converse of the base angles theorem says if a triangle is equiangular, then it is also equilateral. So it goes both ways. If you know it's equilateral, then it has to be equiangular. If you know it's equiangular, then that means it has to be equilateral. So find the measures of angles PQ and R in the figure. Since we know that all three sides are congruent to each other based on the markings, that makes it an equilateral triangle. So we know that all three angles have to be equal. And how many degrees are in a triangle? 180 degrees. So there's three angles divided by 180, or 180 divided by the 3, and that gives you 60-degree angles for all of them. So your angles in every equilateral triangle are always going to be 60 degrees. Lastly, find the values of x and y in the diagram. So this seems pretty hard if you look at the figure. But if we break this down into two separate triangles instead of the one big triangle, it's going to help us. So first, we see that this triangle here that one is equiangular. So that tells us that all the sides are equal. So if this side is 4, then that tells us that y is equal to 4. Also tells you that this side is equal to 4. Okay? Then we can look at this second triangle here and see that it's isosceles based on our base angles being congruent. So since those are congruent, it tells us that these legs also have to be congruent. So you get 4 equals x plus 1. Then you just solve. X equals 3. Okay, it's probably the easiest section of the chapter. Not too bad at all. All the calculations are going to be fairly easy. Remember that if it's an equilateral triangle, all the angles have to be 60, and all the sides will be the same. You have one more section left in this chapter, which means you're looking at a chapter test probably next week or so. I'm looking at like maybe Friday, Monday. All right. Let me know if you have any questions. I might start posting some like reviews of the homework at the request of some students. Let me know if you are interested in that.